morning. Assalamualaikum and good morning. So today we are going to continue with 3.3 man-made satellites. Okay, so in your lower form, when you were in form 3, you have learned about space technology. Awak ada belajar tentang space technology kan? Okay, including space shuttle, rockets and so on lah. Okay, antara space technology that you have learned and are going to learn today is satellites. Okay, satellites yang awak dah belajar. Before this, awak ada belajar tentang ISS, iaitu International Space Station. And then awak ada belajar juga tentang MISAT. MISAT is Malaysian satellite lah. Tiongsaat, Razaksat and so on. Okay, so ni kita record sikit-sikit sahaja. Okay, so you have learned before in 3.1, okay, here, for an object launched from the earth, the object needs to be launched at specific speed. Dia perlukan specific speed lah, linear speed kat sini. If the speed is low, kalau speed dia low linear speed, the object will fall back to the earth. Dia akan jatuh balik ke bumi. But if the object is launched with sufficiently high linear speed, so the object will follow the trajectory. Kalau speed dia tinggi, dia akan follow the trajectory dan dia tak akan jatuh lah. Dia akan ikut je kat sini. So this is what happened with satellite. Okay, so satellite requires specific speed in order for it to circulate around the earth. Okay, so kita lukis. Okay, so you have earth and satellite. Satellite orbiting the earth. Okay. Okay, so let's say the mass of the mass of earth is m. Mass of earth. And then we have small m, which is mass of satellite. Okay, and then we have radius of orbit of satellite r. Okay, radius tu adalah from the center of the earth sampailah dekat orbit tu. Okay, so this is r. This is we call as radius of orbit. Okay, next, we know that the satellite is orbiting at a specific speed. Okay, linear speed dia. Okay, let's say v. Sini. V linear speed of satellite. And we also have t. Okay, t is the time taken for the satellite to orbit around the earth, ataupun nama pendeknya orbital period. Okay, orbital period. Okay, so you know that when you have two objects, they have a gravitational force exerting on each other. Okay, so you learn that before. So we have Fg ataupun gravitational force, which is G M besar M kecil over R squared. Okay, so you have also learned that if an object rotates ataupun undergoing circular motion, if an object undergoes circular motion, it has centripetal force. Okay, where the centripetal force is acting inward ke dalam. So centripetal force is mv square over r. Okay. Okay, so now we can equate these two because Fg, gravitational force, is actually the same as centripetal force. Yelah, sebab objek yang sama kan, satellite. We are referring to satellite rotating, circulating around the earth. Okay, so kita boleh samakan equation dia. mv square over r equals to gmm over r square. So now you can cancel the common factor, which is m boleh potong, and then you can also cancel r. Kat sini ada r square, sebelah ada r, so kita boleh cancel salah satu r lah, so dia akan jadi satu r je. Then you are left with v square equals to gm over r. You square root the right side, you will get gm over r. So apa itu gm over r? Okay, so this is actually the linear speed of satellite. Okay, so ini dah dia speed of satellite orbiting around the earth. Okay, so kat sini awak dapat tengok the factors affecting the linear speed is radius r, radius of the orbit, g and also m. Tetapi g and m is constant. Okay, g and m is constant. Kita sambung kat sini. Okay, so v equals to gm over r. But gm is constant. Kenapa cikgu kata dia constant? G is constant lah, gravitational constant. M is actually the mass of the earth. Mass of the earth does not change, sebab tu kita panggil dia constant. But r here, r kat sini, dia boleh berubah depending on the position of the satellite. Kalau dia jauh, r dia tinggi. Kalau dia dekat dengan bumi, r dia rendah. So, meaning here, the speed of the satellite only depends on r. Okay, so speed of the satellite, the linear speed of satellite depends on r. Okay, so now kita pergi spesifik sikit So this is Earth. Okay, and we have orbit, and we also have satellite. Okay, macam ribbon ni. Okay, so now you know that the formula V equals to gm over r, where r is the orbital radius. Okay, orbital radius ni adalah from the center of the earth until the orbital orbit lah, sampai orbit kan, ini r. Okay, kalau kita nak be more specific, r ni, okay, ni adalah r. Okay, r ni sebenarnya adalah radius of the earth, betul? Radius of the earth plus h. Okay, radius of the earth sampai sini. H pula height of the satellite from the surface of the earth until the orbit. Okay, so kita pecahkanlah. R is the radius of the earth plus height of the satellite from the earth. So kalau kita substitute dalam ni, kita akan dapat V equals to G M over R plus H. Okay, so this is the formula for linear speed of satellite. Okay, so sekarang kita tengok satu contoh. For example, let's say we have Earth, then we have orbit and satellite here. Okay, so this is GPS, Global Positioning System, satellite yang digunakan for navigation for fun. Okay, So let's say the height of the satellite, okay, the height of the satellite from the surface of the Earth is 2.02 times 10 to the power of 7 meter. Okay. The radius of the Earth, as you already know, you should know by now, is 6.37 times 10 to the power of 6 meter. Okay, I don't expect you to memorize the radius of the Earth, the mass of the Earth. Tidaklah, dia akan diberi. And what else do we need? Okay, kita tengok balik equation dia. Okay, V equals to square root of GM over R plus H. Okay, the question asks what is the speed of the GPS satellite. Okay, apa speed of GPS satellite? So, kita dah ada tadi GM over R plus H. Okay, next we need mass. Mass of what? Mass of the Earth. Okay, mass of the Earth, bukan mass of the satellite. Kenapa kita tak perlukan mass of satellite? Because we have already cancelled. Dalam derivation tadi kita dah cancelled mass of satellite. So what we need is mass of Earth. Mass of Earth is 5.97 times 10 to the power of 24 kilogram. Okay, so now you have all the information. Just substitute into the equation. Okay, V equals to G adalah a constant, gravitational constant. 6.67 times 10 to the power of negative 11 times mass of the Earth 5.97 times 10 to the power of 24 over R dia 6.37 times 10 to the power of 6 plus height of the orbit 2.02 times 10 to the power of 7. Okay, so be very careful when you put all the numbers in your calculator. Masukkan betul-betul, then you will get the speed of the satellite is 3.87 times 10 to the power of 3 meter per second. Okay, so that is the speed, the linear speed of satellite. Okay, so for this value, okay, specific untuk GPS satellite lah, meaning that if the speed of GPS satellite is lower than 3.87 times 10 to the power of 3 meter per second, what happen is the satellite will fall back to the Earth. Fall back to the Earth. Okay, but what happen if the speed of satellite lebih tinggi daripada 3.87 times 10 to the power of 3? What happen is the satellite will rub against the air resistance. Okay, kalau dia laju sangat, dia akan rub against the air resistance. So this will cause heat. Dia akan menyebabkan heat produce and eventually cause the satellite to burn. Dia akan terbakar. Okay, so bila dia terbakar, habislah, tak berfungsi dah lah. Heat and then cause burn. Okay, so that means that the satellite require a specific speed. Okay, dia perlukan specific speed in order for it to orbit around the Earth. Okay, so I think that's all for this video. For the next video, we are going to continue with geostationary and non-geostationary satellites.